Hey guys, welcome to another video. This one we're working on minimum difficulty of a job schedule. And let's just throw this thing on. So you want to schedule a list of jobs in D days. Jobs are dependent. To work on ith job, you have to finish all the jobs. Okay, so you have to do them in order. To finish at least one task every day. The difficulty of job schedule is the sum of all the difficulties. Difficulty of the day is the maximum difficulty of a job done that day. Given a job difficulty array integer D, difficulty of ith job is job difficulty I. Return minimum difficulty of a job schedule. If you can't find anything, return -1. Okay. Okay, so it looks like basically we can do as many as we want per day, but we have to do at least one. And then the difficulty for that day is the max for the day. So like if we do this, this would be like a 6, and so on. Okay, so they tell you that. Okay, so you do the first 5 jobs here, which is 6, then 1. Okay. So here you have 4 days and you have 3 jobs, so you just don't have enough. Then here you do 1 a day, so you get 3. This is 300, so let's write down some of this. So you have 300 jobs, 10 days. Let's rename this. Okay. So I think basically the choice is like on every day you can do as many jobs as you want. So I think we can do this in like DP. So basically our DP state would be like index day, and then we loop through jobs. And so we can take however many like jobs for the day and recurse to the next one. And then our base case is going to be when we're done. So that's obvious. Done. Then you have 0. And then you can have some edge cases or like some cases that don't work. Basically, you just don't have enough. So like another base case is done with days, but we still have jobs left over. And in this case, we want to return like infinity or something. So we can return like infinity here. And if it was success, then we do this. And this will give us like the min. And the time complexity here is going to be, so we have an index in the jobs. We have days. And then every day we loop through all the jobs again. So it's like I squared times days, which is 300 times 300 times 10, which is fine. Yes, I think let's go with that. And I've just been doing bottom-up DP because top-down, some problems you get TLE and stuff. So, and I'm a lot better at top-down. I can do that very quickly. So I just want to practice bottom-up. If you are new to DP, I'd strongly suggest doing top-down first. Okay, so have DP. So basically, we can write down this dimension. So dimensions is jobs, or like index in the jobs. And so actually, like what's the top dimension? So it's actually going to be the day. So day and index in the job. Okay, so this is basically going to be an array repeating. So this is like for every day. So here you just have days. So we need 0 to the last day. So it's like this. And then this. Yeah, basically array repeating. And I think this is also jobs plus 1, because like we want to be done with the jobs. I screwed this up. Yeah. So this needs to be this. I also screwed this up. Yeah, so this is not this. This is here. We'll just make everything infinity. And then we'll make our base case 0. So, Okay, so basically this is the columns, and this is the rows. So the columns will be the index and the job, and then yeah. And in Swift, count is basically length, and then repeating just means this is like the value. So it's kind of the same thing as in Java, like array fill. So this is the value fill with, this is the length. All right, so base case. So when we're done with all the days, which is days, and when we're done with all the jobs, so let's make another length. Or something like that, sure. Maybe you can make this a better. Maybe you can say this is difficult. Just say num jobs. Okay, so this is like num jobs. So when this is done, then the base case is 0. So for every day, basically the recursive case here is wherever we're at in the jobs. Like let's say we're here on some day, we try to loop through all of it, and however many jobs we take, we keep running max, and then we recurse to the next day and the next index. And we need to go through it backwards because like if we're on day 1, that's gonna recurse to day 2. If we're on day 2, that's gonna recurse to day 3, and so on. So we need to go through this backwards. So we can say like for day in stride is basically just a for loop. So from days -1. So like if we have 2 days, we'll have like day 0, day 1, and then day 2 is when we're done. So through is just up until this index and including, so 0. By is the step. And then we need to also loop through. So this is the day when we can start through every starting index. We can do some optimizations, but it doesn't really matter. Like we can say like if we're on day 5, we can start with job 5 because anything lower won't have a solution, but it's not going to matter. We can just kind of do the normal thing. So here we're going to say, so this is like the starting index. So we can say like for start in 0 to num jobs. Basically, like we can start anywhere. Okay. So for every day, we can start anywhere. This is like the 2DDP. And now we have to start anywhere. We have to loop through the end. And we need to maintain a max count as well. So we can just say like var or max difficulty equals. So we'll make this here, and then we'll move as we go. Okay, so now we need a third loop. So for I and start num jobs. So maintain the max difficulty. So max I think it's actually yeah, it is the max. Okay, max difficulty. And then jobs I. So this is the current difficulty. So if we add like if we're in some case, because we filled this in with int max, we can't just like do something plus this, because then we'll get like overflow, or like, yeah, basically we'll get overflow. Kind of 2 ways to handle this. We can either not make this int max, we can make it something smaller. So if this is like 1,000, we can make this like 10 to the 9th or something. And then you can do a strict add, and then you can just check at the end like how big is your number. But alternatively, we can just calculate the DP of like where we're going, and if it's int max, that means that like it's kind of like no solution, and we'll just skip it. So let's do that. So let recursion or something equals DP. So basically, we're going to take this max difficulty, and we're going to recurse to DP of, so this is going to be day +1. So it's like the next day. And then the job we're going to start as the one right after this one. So I +1. And if this is out of bounds, then like if this is infinity, then we skip. So if recursion, if this is some illegal case, we'll just continue here. And if it's not, then we'll just minimize. So day and I equals min dp day and I, and the recursive case, which is, so this is max difficulty because this is what we take today, plus the recursive case. Even though we're not recursion, like we're technically not recursing, but we're going to the next DP case. Okay, so we can maybe even call this like remaining or something. Remainder, maybe that's better. Okay, so it's basically just saying whatever we had before versus take the max, like maintain this running max difficulty plus the next, like everything else for the next few days or the next full set of days. So then we can just return. So we start at day 0 and we start at job 0. But this could be, like in this case, we should get infinity here. So if this is, so this is this pretty common trick. You just check like, what's your answer? Is it infinity? If it's infinity, then we basically can't have a solution. So we'll just return -1. Otherwise, we'll return this. So let's see if I screwed anything else up. I did. Repeating count. Definitely did. So incorrect. Have repeating that I misspell. Oh yeah, I did. Really annoying that in Swift they don't show you errors. Cannot convert int to int. Int array to int. Oh. So this is not jobs, this is numjobs. Okay. Okay, we got -1 for some reason. Why is that? Yeah, there's definitely a solution here because basically whenever you have, so we can check for one more thing, but I don't think it's going to matter. Basically, we can say if the number of days is less than the number of jobs, then we can return -1. But I don't think that's going to matter. So if days is less than num jobs, return -1 because we just don't have enough jobs. Or actually more. If we have more days, like if we have 4 days and 2 jobs, we can't do anything. But I don't think this will fix this one. Yeah, so we got -1. So why is that? What do we screw up? Days. Okay, so repeating. Okay, so basically whenever we're out of jobs and out of days, that's the only one that should work. Which in this case, so we have num jobs is 6. So this would be like day 2, 6. That's fine. Start difficulty. Okay. Let remainder equals the next part. If it's infinity, continue. Otherwise, dp day I equals min dp day I, which is, it's not I, is it? It's start. Yeah, because we always start. Like our dp is day and start, not I. So this should be start. This should be I here. I think that's correct. Okay. Okay. So here with bottom up, because it's already in bottom up, you can kind of look like, can I improve anything? And we can see that our DP relies on always, or this case, this remainder, always relies on the next day, right? So like whatever day we're on, it relies on the next day. So then what we can do to make this better is instead of making this a 2D DP, we can make this a DP just for each day. So we can get rid of this. So this is basically saying this is for the last day. And then this is this. And you can see how easy it's going to be to change it to one-dimensional. So basically all we have to do is declare a new DP here. So we can just copy it. so int max, now how many times do we want to make this? I think this is fine. And we don't have a base case in this DP. So this is basically saying, like, for the previous day, make everything infinity. And now all we have to do is change all the 2D DP references to 1D. And then at the very end, we can just say DP equals DP here. Okay, so what we can do is we can say, like, okay, so like here, for example. So this is DP day plus 1, but DP day plus 1 is just DP because DP is going to be for the next day and new DP is for the current day. So this, we can get rid of that. And now this is new DP. And new DP day is just new DP. So this is just the same. And yeah. And now this is one dimensional. So this is just this is day 0 already, and then we just want job 0. So now we can make it smaller. And that's the nice thing about doing bottom up right away is you can space optimize quickly. So it's just a little bit, at least for me, it's a little bit more tricky. Like top down is very easy to be like, okay, these are my base cases. This is how it occurs. Like it's easier to see, in my opinion. So I would recommend this once you are very comfortable with top down. Because yeah, for LeetCode in particular, a lot of these top downs, TLE, well, not a lot, but a decent amount. For interviews, I'd probably just do top down just because way less room, or way less likely you make a mistake. Okay, so I can get rid of all that. Okay, so going through time and space. So I think I mentioned this already, but basically, so we're looping through every day. So that's like day. We also made jobs here, but we're looping through every day. We're looping through every job. And then we're looping through every job again, essentially. So this is like day times jobs squared. In space. So we had day times jobs, right? But now we have just a jobs DP array. So this is jobs. And yeah, I think I mentioned this before, but in LeetCode and in OAs and all that stuff, when they give you constraints, you can kind of know what's the top bound. Like basically the most you can have is somewhere around 10 to the 7th. So I know that like, okay, if I have 300 jobs, this squared is what, like 9K or 90K. And this is this. So this is like 9 times 10 to the 5th, which is under 10 to the 7th. So that's how I knew that this would be fast enough. If this number was like 3K, then it would be like really close. If this number was like 30K, then I knew this wouldn't work. And the general case that made me go towards DP is because you have like a choice of doing, you know, X or Y, or like take as many jobs as you can. And so that kind of thing usually goes towards DP. Usually it's like, if it can fit in DP, DP is kind of like a brute force for harder problems. Like if the constraints are small enough, you can have enough state, you can always make DP work. If you can't do that, then it's like some crazy optimized DP or it's something else. But yeah, that's going to be all for this one. Hopefully you liked it. If you did, please like the video and subscribe to the channel. And I am going to do, I think, like 4 or 5 mock interviews tomorrow. And I'm going to post those on here. So let me know if you guys enjoyed those. And if you want to sign up, feel free. The link's in my YouTube. All right, so I'll see you.